Okay, so we are going to be looking at 1.1. We're looking at solving some equations here. So let's take a look at some examples here. So there should be some nice review. Let's solve each equation. So our first example, we have 8y minus open parentheses 3y minus 21 close parentheses equals 46. So remember, when it comes to solving equations, the first thing we want to do is we want to distribute. And keep in mind that this is a negative, right? We're going to distribute this negative to each one of those terms. And distributing that negative symbol will eliminate that parentheses because we never want parentheses. So that distribution will leave us with an 8y minus 3y plus 21 equals 46. All right, once again, negative times a positive. This is a negative and a negative makes that 21 a positive. Okay, from there we want to combine some like terms. These two terms, in fact, are like, so we can combine those. We get 5y plus 21 equals 46. From there, we're just trying to get this y by itself, so we want to get rid of this and that. We get rid of the constant first, and then we get rid of that coefficient. All right, so we do that by subtracting 21 to both sides. That cancels out. We're left with 5y equals. We subtract there. This is 5. 4 minus 2, that's 2. So we get 25. And then our last step, this is 5 times y, the opposite of multiplication. We just divide both sides by 5. Cancels, cancels. We get this answer here to be 5. So nice first example of solving an equation. So a little bit of review. How about our next one? We have 8 open parentheses 4x plus 6 close parentheses equals 11 minus open parentheses x plus 7 close parentheses. Once again, anytime we have an equation and we have parentheses, we want to get rid of parentheses, so we distribute. All right, the same thing, this negative, we're going to distribute. Right, 8 times 4, that gives us a 32x. Right, then we do 8 times 6. All right, we do this 8 times 6, and our 8 times 6 gives us a positive 48. We bring our 11 down, and now this negative is going to get distributed to that x, making that a minus x, and then this negative gets distributed to the 7, making it a negative 7. Now we're looking to combine like terms separately on each side individually. We can't combine these two. On this side, we have this 11 and this negative 7 that we can combine, right? We have 11 and minus 7 that can be combined. So I bring down my 32x plus 48, right? And I do my 11 minus my 7. That gives us a 4. I bring down my minus x. Okay, so I simplified the left side, simplified the right side. I can't simplify any further. I see I got x on the left, x on the right. I'm going to get rid of the smaller one. This is a 32x. That's a minus x. So I'm going to get rid of a minus x by doing the opposite of a minus x, which is a plus x. Plus x. Right? And I can combine here 32x plus x. Remember, that's like a 1 in front of that x. So that gives us a 33x. Bring the rest down here. I bring my 4 down, and I see that cancels out. Now this problem looks just like our previous example. I want to get x by itself, so I got to get rid of this 33 and that 48. But I can't get rid of the number in front of the x yet, so I get rid of this 48. That's plus 48, so I do the opposite, which is a minus 48. Minus 48 cancels. Left with 33x equals, and this gives us a minus 44. All right, next step is just to now divide, right? We could divide by 33, divide by 33, cancels. We're left with, let me put this by the side, x equals a negative 44 over 33. But this does in fact reduce. It looks like we can probably divide each one of these by 11. So we get negative 4 over 3 as our answer to this nice example. Let's take a look at some other examples on this 1.1 homework here. I think, well, how about one of these with fractions, right? We have 6 over 7x plus 4 over 14x equals 48 over 14. So a very nice example. I know people look at this, say fractions looks ugly, but let's not forget one of the things that we can do is we can first find our LCD, right? LCD. And don't forget how to do that. I think students sometimes forget how to do that. Right, you can multiply by 1, multiply by 2, multiply by 3, multiply by 4, and you keep going, right, until you find a number that they have in common. Right, so 7 times 1 is 7, 7 times 2, 14, 7 times 3 is 21, 7 times 4 is 28. 14 times 1 is 14, 14 times 2 is 28, and you continue, but I see that the smallest number they have in common is 14. So my LTD is 14. So because of that, what I'm going to do is I'm going to multiply each one of these parts, each one of these terms by 14. All right, so times 14, times 14, times 14. And what we're doing here, this whole thing is 3 math operations, right? So have your calculator out. You do 6 times 14. All right, that gives you a number like 84, right? So now you have 80. All right, so we have 84 over 7x plus 4 times 14. You have 56 over 14x. Oh, that should have been a 14 here, right? 48 times 14, that's a 672. All right, now divide. Right? 84 divided by a 7. Well, now look at that. That's a 12x. 56 divided by a 14. Look at that. That's just a 4x. 672 divided by a 14. Look at that. That's a 48. So really what we did was something very nice. Our problem started off with all these fractions. We transformed it to a problem with no fractions. Fractions, no fractions. This process is called transformation. And we do that by finding the LCD, and we multiply each part by the LCD. Makes it really nice, really nice. Okay, 12x plus 4x, we combine those, we get 16x equals 48. Your last step then is to divide each side by 16, and it gives us a nice answer of 3. So anytime an equation has fractions, we can always do that. Makes it really nice to work with. And let's try to do one more here. I think there's a nice example where maybe the problem has a little bit more parts to it. I think I see one, if I'm not mistaken, one that has parentheses, brackets. I'm just scrolling through your homework and seeing what I can find here. All right, well, this will be our last example. How about example D? We have a 3, open brackets, 5 minus 3, open parentheses, 4 minus x, close parentheses, close bracket, minus 5 equals 5, open bracket, 3, open parentheses, 5x minus 4, close parentheses, plus 2, close bracket, minus 26. So we definitely see a lot going on with this problem. Let's go ahead and take a look at it. So let's get rid of the parentheses first, right? We see bracket and parentheses. So we want to work from the inside out. So let's just start here. Let's get rid of this in the inside of this first set. And in here, let's get rid of this parentheses in the inside. So you work your way in, out, okay? So we get 3, open bracket, 5, all right? We distribute this negative, and keeping in mind that this is a negative that's going to get distributed to both. So that's a negative 12 plus 3x. We bring back our closed bracket, minus 5. So you could already see really nice. We had parentheses, and now we don't, right? We've already removed some of it. Okay, moving on to the right side. 5, bring that down. Open bracket, we bring that down. And now we have this 3 that we're distributing to both there, right? So that's a 15x minus 12 plus 2. Close down our bracket, minus 26. It's again really nice. We had parentheses, now we don't. You have a couple of options here. I'm going to continue to get rid of parentheses, this time brackets, right? So I'm going to distribute 3 to each one of these terms. Right, so that's a 15 minus, that's a negative 36. That's a plus 9x minus 5. Really nice. You can see now we have no parentheses, no brackets, just terms. We do the same thing over here. Distribute this 5. So we get a 75x. All right, now we have 5 times our negative 12 gives us a minus 60. 5 times 2 gives us a plus 10. All right, so problem looks really nice here. Now from here, all we have to do is combine our like terms. I see I got 15 minus 36 minus 5. All of those are like terms, right? 15 minus a 36 minus a 5. That gives us a negative 26. And we bring down our 9x. It looks like 75x is by itself. And then these are our terms that we combine there. All right, we have the 60. That's a negative. We're going to add a 10. We're going to subtract the 26. That gives us a minus 76. I see x here, x there. This is my smaller one, so I'm going to get rid of that. Again, when you have them on both sides, you get rid of the smaller one. Bring down our negative 26. 75 minus our 9 gives us 66x minus 76. We want x by itself, so we got to get rid of both of these. We get rid of that last, so first we get rid of that minus 76 by adding it to both sides. This gives us a 50 equals a 66x. All right, now we just divide both sides to 66. All right, so we get 50. over 66. So it looks like it can be reduced, right? Well, what happens if we divide both by 2? That gives us 25 over what? 33. All right, and I think that's all we can do there. So that's what we get as our solution there. So a nice example there. And I just want to show you the process on another one here. We won't completely work it out, but let me at least start you off on it. 1 over 8, open parentheses, 8y plus 16 minus 7 equals negative 1 over 8, open parentheses, 16y minus 32. This example is interesting because what we see once again is fractions, right? But we also see parentheses, right? So we find our LCD, right? This one is nice and easy because all we have is 2 fractions, so our LCD is definitely 8, right? And all we're going to do when we're getting rid of fractions in the equation, you multiply everything except inside parentheses, right? By the LCD. So that means this gets multiplied by our LTD. This is inside the parentheses, so none of that. This negative 7 gets multiplied, and also this right here. All right, doing that then leaves us with the 8 over 8, open parentheses, 8y plus 16 minus your 7. Negative 7 times 8 is minus 56, right? And now you get negative 8 over 8, 16y minus 32. All right, and then you see now that turns into a 1 because 8 divided by 8 is a 1. And then from here, right, this is a negative 1. And then from there, you can go ahead and continue the way you would. So you'll see a problem like this. I just kind of want to show you the steps on getting it started there. Should be able to continue. I won't continue there. Okay, if you have any other questions on 1.1, just by all means shoot me an email. Thanks.